welcome back to my channel again. So today I'm going to introduce something a bit new in maths and carry it along with what we have been doing so far, because I think it's boring for you, because if every day I have to come here and tell you about the geometry, then you may not even want to watch me anymore. So today I'm going to give you something called trigonometry. Precisely what is trigonometry? Trigonometry, as the name suggests, is the study of triangles, and more specifically is the study of right angle triangle. Now in this we have something called SOHCAHTOA, which is pretty common. If you ever went to a maths class, you must be knowing what SOHCAHTOA is. There are people in this channel who may not know anything about maths, and I'm interested to carry them along, so I'm going to tell them what SOHCAHTOA is, and then do a few things to illustrate these things. So SOHCA means, I have to write it down first. What it looks like is SOH, car and TOA. Very common stuff, very common in trigonometry. If you ever attended a class of trigonometry, you know already what this is, and you can skip it. But for those who don't know, this is something called SOHCAHTOA. Now here, this stands for sine, is opposite of hypotenuse. Now let me draw a right angle triangle to illustrate this point. Okay, this is a right angle triangle. This is 90 degrees. Maybe it's better for me to show you the degrees. This angle theta, this is 90 degrees. Here it looks inverted, but from there I know you are seeing it as 90. Now, so this side, let me write and show you. Hypotenuse, adjacent, opposite to angle theta. So angle theta would be here. So I've written this stuff. You can, this opposite and adjacent, and that is hypotenuse. Hypotenuse is the longest side of the triangle. So opposite is in relation to, oh man, it's really getting my camera out of my chest, and I don't know how best. Let me draw it and I'll show you. So I put the arrow. It's opposite to the other angle theta is this one, so this becomes the opposite. Now that's hypotenuse. Next to this angle is the adjacent, this one. So that's, now the formula is that sine is opposite over hypotenuse, right? Yeah, sine is opposite of hypotenuse, and the opposite is this one, hypotenuse is that one, and cosine is adjacent over hypotenuse, adjacent, which is this one, over hypotenuse, and tangent, how you pronounce it, is opposite over adjacent, opposite over adjacent. It's very simple, and that's what it stands for. So if you see SOHCA, I mean sine is opposite of hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, and this is called SOHCAHTOA, very famous in trigonometry. This name is very, it's what do you call it? Is it mnemonics? Yeah, in short form of what it all means. So here we want to calculate angles, cosine, sine, and there are more than, we have also more than that. For example, there are 6 of them. We have also secant. Secant is opposite of adjacent, but I think I'll bring that in the next topic. I don't want to confuse you. I'll give you a lot of stuff. There are 3 more. If you follow, next time I'll show you what they are. Okay, 3 more are there: secant, cosecant, and cotangent. But for today, I'm going to show you sine, cosine, and tangent. Okay, tangent. Sorry, I pronounce it tangent. Tangent. So, okay. So we're gonna give real values to this thing, then calculate. Okay. So let's give, for example, I'm going to clean this thing and draw another one just to show you what I mean. I'll show you in a minute. Sorry guys, I have to do this because my board is not fixed on I don't have a cameraman. So since I'm doing it to myself alone, that's how I have to do it. So I hope you understand and we get along. So this angle theta and this is 90. So I've drawn this thing again. I'm now given real values, and from SOHCAHTOA what I showed you, you know, this is opposite as hypotenuse, this adjacent. Now we want to calculate the sine. What the sine theta of this thing, or this stuff, this triangle. What is the sine theta? According to what I told you, sine theta will be already in white. It's going to be this over that, opposite over hypotenuse. Now opposite of hypotenuse means it's going to be opposite is 5, opposite to this angle theta, opposite. If you follow this angle, it will take you like this. What is opposite to this angle is this thing, and this becomes the opposite. Now let me not confuse with this arrow. I'm just trying to illustrate to you the point. So we're gonna put 5 over 6. 5 over 6. Now 5 over 6 is gonna give you the hypotenuse of this thing. Okay, 5 over 6 is the hypotenuse. So it's gonna give you the sine theta. I'm confusing this. Sine theta is going to be opposite of hypotenuse, it's gonna be 5 over 6. Now I have to keep cleaning. So SOHCAHTOA, you already copied that down, you know it. So sine theta, I'll show you, which is equal to opposite over hypotenuse. Hypotenuse, in short, I'm writing it in short, is 5 over 6. Okay, sine theta is equal to opposite of hypotenuse, which is equal 5 over 6 from this triangle that I drew. I've cleaned it, but I can do it again, no big deal. And we have 5, 6 and 4. Okay, so I've given this value there, that one. Now let's calculate the cosine. Now cosine, this is really simple maths. I think you all know this if you ever went to a math class, but maybe you have forgotten. So I'm trying to remind you a bit of your maths, or maybe you have kids and you want to teach them this stuff. Okay, so this is going to be adjacent of hypotenuse, adjacent of hypotenuse, which is 4 over 6. 4 over 6. This one, this 4 over 6, which means you're taking it 4 over 6. That's adjacent over hypotenuse, right? Are we together? I hope I'm not going fast. 4 over 6. Just follow me along. Cool. Now let's go to the last one for today. As I told you, I don't want to bombard you with maths and then you forget. You'll find it difficult to follow if you ever not. Maybe you are seeing this for the first time, so it will confuse you if I give you a lot of material at once. I told you, follow me guys, you learn maths from me, assuming you never went to a maths class. So we are going to do the tangent. Okay, tangent is opposite of adjacent. Now you know what's opposite. According to this is 5, and we have the angle theta here. It's the angle theta. Okay, opposite of adjacent, and opposite is 5, adjacent is 4. Okay, so tan theta is gonna be opposite, which is 5 over 4. It's gonna be 5 over 4. So tan theta, I've shown you here, tan theta, we call this angle theta. So I've not put the angle here. So tan theta, okay, I think it's very simple. Tan theta is equals to opposite of hypotenuse, which is this one. Adjacent. I really confused this. I'm also human, I make mistakes. Tangent, tan theta is equal to opposite of adjacent. Opposite is this one, and adjacent is this one. Okay, so it's gonna be, according to this thing, you see this is what? This is 5 and this is 4, so it's gonna be 5 over 4. Okay, yeah. So you've seen that, and there is a formula actually for it. We can label the formula as well. Let me label the formula. Another formula is which you call Pythagoras theorem. I think it's called Pythagoras theorem, which shows that a squared plus b squared is equal to c squared. Okay, that one, a squared plus b squared is equal to c squared. That, in other words, suppose now which one is a? It depends how we label them. Let me remove this thing first. C squared obviously will be the longer side, so that means C will be the hypotenuse side, and A and B. So how you name it? So A will be adjacent. Let me see. A will be adjacent, and I think this one, you can name it the way you want. You can say A is this one, B is this one, and C is this one. It doesn't matter how you name it. So say this is adjacent, this is opposite as hypotenuse, and that formula there shows that if you multiply, square this and square that to be equal to that. For example, let's say this is 4. Does it look like, it looks like longer than this? Yeah, let's give it the value, longer value. I drew it the wrong way. I think I should make it short. Sorry guys, I'm not looking at your face. Okay, let me give it 4, give this 5, and give this 6. And from what I've told you, you know this is adjacent, this opposite, that's hypotenuse. Now, according to this formula, Pythagoras theorem, now let's square this. This will be what? We will square 4, it will be 16. Because look, 4 times 4. 4 times 4, square 4 means 4 times 4. This thing will give you 16. Okay, we write it 16, and square 5 will give you 25. So it's 25. Let me see. Yeah, and this one, I'll show you in a minute. Story 1. No, something's wrong here, terribly wrong. Yeah. This is 16 plus 25. It won't work like this. I think that I gave the wrong values here. Let me see. If you square the hypotenuse, it will be 36, right? And if you square 4, 16, and you square 5, that's 25 plus 16. No. There are values here which you have to follow. They relate to right angle triangle. I think I'm giving you a lot of stuff, but let me just write these values. Right angle triangle values to remember is 3, 4, 5, 5, 12, and 13, and then 8, 15, and 17. And actually basically 1, 2, 3, 4. There are 4 of them which are commonly used. Is 7, and 24, and 25. These are commonly used, but there are more than that. There are also 2 more which I'll show you in the next video. So let's assume that this is the adjacent. This is the adjacent. This is the opposite. This is hypotenuse. Let's see, if you square this, 3 will be 9, and if you square that, it will be 16, right? So 16 plus 9, what is the answer? 5 with 1, that's 25. Okay, 16 plus 9 will be 25. Now if you square C, which is 5, it also give you 25. Now this follows obeys Pythagoras theorem, guys. I'm sweating so much. I think I'll stop this video here. I'll continue from here. This is, let me give you this value and stop here. That's 3, 4, 5. 3, 4, 5. So I'm drawing a triangle. This place here is very hot, my dear. Now to switch off the fan to show you this, I'm sweating. So it's a little longer, this one. I'll show you in a minute. So I'm terrible in drawing, man. I'm terrible. That's 3, 4, 5, for example. Okay, this is right angle triangle. You can see this is a right angle triangle here, and this angle theta here, angle theta here. I'm not looking. I'm trying to draw without looking, but it's not possible. I have to look. So there. So I've given you 3, 4, 5. Okay, this is adjacent. This is opposite. That's hypotenuse. So let's square this according to a squared plus b squared is equal to c squared, which is Pythagoras theorem. Okay, a squared plus b squared is equal to c squared. So let's assume this is a, this is b, and this is c. So I'll label there. Now let's square 3. This will give you 9 plus square 4 to give you 16. Now suppose we don't know this value. Let's say we didn't know this value is x. This value is x. We don't know it, but if you follow the formula here, we're gonna know it, because it says that if you square these two, we square this, we add this to give you the square root of that. So this plus this is 9 plus 16. This one will give you 25. So we're gonna find the square root of 25, which is equals to 5. Okay, the square root of 25 is 5. So we know that this x, this side, it's 5 from this formula, Pythagoras theorem. So we write it here, 5. Okay, are we together? And the light, this light, I don't know what to do about it. I think now you can see clearly. Okay, this squared plus that squared, this is 9, 3 squared is 9, 4 squared is 16. If you add these two, they'll give you 25, a result. And according to that formula, it says a squared plus b squared is equal to c squared. So these two have given you 25. Now that one is c squared, means you have to find the square root of the result of these two. The result of these two is 25, and you find the square root of 25 according to this formula, and it will give you the missing side, which is 5. Okay, it will give you 5 because the square root of 25 is 5. Okay, man. Right? So that's enough for today. We'll continue this thing. I'm sweating too much. please like, share, subscribe, as I bring you more about the smarts. We just introduced trigonometry, and we'll bring on like rompas I didn't do in geometry because you're getting bored, you know. Okay guys, please share, like and subscribe and comment. Bye.